Good morning. Our team for this project is composed by Juan Diego Plaza Gomez and me, Jason Leonardo Gonzalez Huertas. And today we would like to share our development in the control and supervision of a palletizer machine with a PLC and a cloud-based system. All of this in the environment of a digital twin that is afterwards deployed to the actuators in the plant that are in our lab. This project has been realized in the Universidad Nacional de Colombia for the third project of the subject SCADA in June 2022, under the tutorship of the master's degree professional Eduardo Barrera Padrón. The requirements of the project are as follows in this video. The palletizer has two feeder conveyors. In the conveyor above, the palletizer is being fed with boxes, and downwards we are feeding with pallets. The first step is to set up the elevator with a pallet and put it into position to receive the boxes. The boxes are being organized in two different configurations, 3x2 and 2x3. Both configurations are possible with the help of an actuator that does the turning in each iteration if necessary. Once the pallet is full, it clamps the boxes and the plate opens, creating a layer. The process repeats with alternating configuration layers until the pallet is complete with 3 layers. Once this is accomplished, the elevator goes down and the filled pallet goes to the end of the down conveyor array to the exit, and the process repeats itself. To start, we are happy to share with you once again the facilities of our university and our workspace with the PLC, engines and pneumatic systems. In the automation lab, we can see a board with the power distribution and our PLC. In the slot 0, we can appreciate the Allen Bradley PLC CPU Compact Logix L30ERM, which has the processor and memory. It stores and executes the program. For the control of an engine with a variable frequency drive, we use the analog output module 1796OE4. In our project, we also use the power source from Allen Bradley. We can see as well the digital input module 1769IQ16, which allows us 14 digital inputs for our sensors. At his side, we have the digital output module 1769OW8 that has 7 outputs with which we can control our actuators. In the board, we can also appreciate the start and stop buttons. They will be one option to start the whole system. In the first place, and related with our above conveyor, we have the engine system, which is confirmed by the magnetic starter that protects the engine from current overloads, the soft starter that protects the engine from damage caused by sudden influxes of power by limiting the inrush current associated with the engine startup, and our 1 horsepower Siemens engine. The second engine that we can appreciate is a motor that is controlled by the variable frequency drive. This represents the pallet of output conveyor. This system starts with the magnetic starter, the variable frequency drive that allows us to control the frequency given to the engine from 0 Hz to 60 Hz. This is possible with the analog output of the PLC from 0 volts to 10 volts. At next, we have our pneumatic system that is brought by a source with a compressor from the lab and put in our control valve source and distributed to 2 valves. The first one, a 3-2 valve with an electric actuation and a return by spring, which will control our simple active cylinder that represents the plate, and our second valve, 5x2, that is only activated via electrical and control the double acted cylinder that represents the pushing plate. Another important hardware of our project is the PC or laptop, where we will see the factory I/O. As well, another important part is the cell phone, where thanks to Ignition, we will have the interface of our SCADA. For this project, there are 4 main environments in use. Using the ISA 95 convention, in the control level we have the physical environment and the simulated environment in the factory I/O, where the actuators and sensors are, and communicate with the logic. The control level is managed by the PLC of Rockwell Automation that was programmed with Studio 5000. And all the information is sent into a SCADIsh level made with the cloud notepad, where all the historicals, alarms and user interface is displayed. There is also a local notepad that makes possible command sending and basic monitoring through a chatbot in Telegram. In this project we will use the Telegram to send basic commands to our logic and receive basic status. And the cloud notepad with the dashboard, which includes the user interface that will be reachable from any computer or even phone, from where we can see and send all the information necessary. For this project we use 4 different softwares. In the family of Allen Bradley Rockwell Automation we have the RS Links and Studio 5000 for communications and programming of the PLC. For the virtual environment we use Factory I/O and the scene of the palletizer that is included in the software. To create the SCADA interface we use Node-RED in its local form, to create a bot in Telegram and send information to the PLC, and in the cloud form to create the services that communicate with the PLC commands in local, and the dashboard to supervise the process in the internet. The goal of this project is not to show all the logic in the PLC. To give an idea, we share this diagram with a graph set-ish architecture. In yellow, we can see the function of each step, and in green the subroutines that were made to make this happen. The first one is the setup of the elevator that includes activate the conveyor of pallets and put one pallet in the elevator, and by the time it's loaded, the elevator can go up. And the elevator is set. Now we will build each layer in an alternative way between a 2x3 configuration and a 3x2 configuration. In each layer the boxes need to be clamped and dropped in the pallet once a plate opens. The elevator also gets a little down in order to wait for the next layer. Once the third layer is finished, the elevator can go full down and the full pallet to the exit. This process repeats until stopped. In order to show you how all the network works, we will share 3 videos in parallel, those being the physical laboratory, the PC with the factory I/O, and the Telegram chat or Node-RED dashboard. To begin, we have to log ourselves into the database of the Telegram bot. Once we are registered, we can send a variety of commands: the confirmation login, the architecture which is being used, and the basic commands to start the system. We see how every environment responds to this command. Another option of the Telegram bot is the report of the state of the system, and also the report of the state of both actuators and sensors, as we can see in the video. Next, we will put in the start in the dashboard, and we will see all the physical actuators and the virtual environment working. Here, we can see how in the dashboard every LED shows the current state of the actuator or sensor in the field. We see as well how can we change the velocity of the second conveyor to make it one, even control its speed. Another tab of our dashboard is the one involving the historicals and alarms, where we can see how many boxes have we processed and other indicators of the process. The historical are shown in the dashboard and in the IBM IoT platform. The advantages that technologies like the cloud connection give us are pretty broad, as they let us to supervise in real time continuously the SCADA system from the apps we use every day to surface the web. To know more about the new technologies like Node-RED and IBM Cloud is something very important for the development of an engineer, as every time one wants to solve a task, there are good collaborative libraries that are tested and can be used, which let the engineer think in the solution as a big picture and not lose time in the fine configuration. Doing this work made us realize of the big potential of Telegram bots that in this little exercise let us generate a database and to share information with a bigger information structures to complement it. Even if these technologies are going into the field of supervising and control of a plant, they are not the ideal solution because of the big delay in the data transmission. As well, the dashboard does not have the same tools as a big SCADA solution as Ignition have. Both problems are solvable working in the hardware and software infrastructure of the program. The potential of this program is unlimited, and it is dependent from us to develop the new solutions for the future.